Alright, we're here at gotomath.com, working calculus. We're looking at limits and we're solving them numerically. So let's actually scroll down the page a little bit here and take a look at this particular problem. We got the limit as x approaches 3 of x squared minus 9 over 2x minus 6. And we want to find out what this limit is, and we're going to do it using the numerical approach, which is pretty simple, to say the least. Let's bring up the whiteboard. I call the whiteboard. Alright, and what are we working with today? Purple? I don't know, we're working with something. We got the limit as x approaches a number I've already forgotten, so hold on. And had to go back and take a look at that. 2x minus 6. Let's sketch out what this thing could possibly look like. Nice straight lines over here. Alright, we are approaching 3, so we'll just put 3 here on the x-axis. What does this graph look like? Well, what we could do is we could factor this thing. We got a difference of 2 squares in the top and plus 3. Now these are the exact same problems that I use in the next section. Alright, so this is our function f of x, we'll say, and I went ahead and factored everything out. Now as you can see here, we've got a like term in the top and one at the bottom that we could actually cancel out of this thing, and so we're gonna be left with we could say 1/2 times x plus 3, but I'm going to go ahead and distribute this across, so we have x over 2 plus 3/2. Alright, now this function is going to be different. We could call this g of x from this function here, or we could call this f of x, but we have to state in the domain that x cannot equal 3. Alright, because 3 is not in the domain of our original function here, so we could call this f of x, but we would have to state that x cannot equal 3 in the domain. Alright, let's clear that up real fast. But anyway, so this is what it looks like. It crosses at 3/2. We'll say this is 3/2 on the y-axis. That's our y-intercept. Has a slope of 1/2. Right, so we'll just kind of sketch something out here. But this is the point right here that's actually undefined in the graph, because when we plug 3 in, right, we get 6 minus 6 is 0 in the denominator, and also we get 0 in the numerator, and so we've got an undefined point here on the graph. So to find where that undefined point is located, what we're going to do is we're going to take a point, some point that's really close to 3. Now that's not really close to 3, but you know, something really close to 3 here, and then of course, you know, we get smaller and smaller, we get closer and closer. And this difference right here we call our delta x, which I start out in the help button. If you click on that, we start with 0.1 and then we go to 0.01 and 0.001. That is, we're going to have 3 plus 0.1. Now that would be 3.1, and we would be plugging that into our function and finding out. You could plug it into our function here and getting a number out, you see, and then doing the same thing with 0.01, and then we can see where this is going to end up converging, and then we do it on the left hand side, so this becomes 3 minus 0.1, getting that number, which is 2.9, plugging it into our function here and getting a number out. So we're coming in from the left hand side and we're coming in from the right hand side and seeing what those two numbers converge towards, and let's take a look at that. So here we are. Let's just click the answer. We can see that it's 3, but let's click the help button here, and this is exactly what I do. As you can see,